Hi, hello. This is Junichiro Horikawa, and I am going to start the weekly tutorial live for Houdini. Okay, and today's topic that I have chosen is this triangle pattern being animated based on some um, time-based pattern, time-based value. And what it's doing here is just a simple rotation for the triangle on its own area based on the some values on the background surface. In this case, I'm using a noise based value, and that's pretty much it for this one. So I think it's not going to take much time to reproduce this one today. Probably less than an hour. So let's try to do this. Alright. I wanted to make something a bit more complex, and I was spending a bit of time trying to achieve that, but I didn't really work out because of the complexity of the geometry. I mean, if the triangle are being surrounded by six triangle faces, then it would have worked, but the one that I wanted to try out was having a different number of neighbor polygons, so it didn't really work out. So the one that I'm going to show you today is pretty much simple. So I think anybody, even a very beginner of Houdini, could follow, I think. Even though I am going to use a little bit of Vex, not that much compared to the other ones. Hello. Okay, so first of all, I'm gonna choose whatever geometry that I would like to use in order to create some animated triangle pattern. And in this case, I'm going to try to use this big head. Now, I'm going to triangulate this by using a remesh. I could either use the uniform remesh or adaptive remesh. Probably using adaptive remesh might make something more interesting, so I'm gonna choose the adaptive so that you'll have more faces where there are larger curvatures. Okay, and I'm gonna make it smoothen out as well. Make this iteration 10 or 20 or something. Really depends on your necessity. Now the materials are messed up. The UVs are messed up right now, so I no longer need those. I'm just gonna delete that attribute. I'm gonna use the attribute delete to delete the texture related values such as the UV and the material from inside a primitive. Okay, so that I can get rid of those unnecessary information. Now, what I am going to do now is to look at each triangle and try to rotate itself in each triangle within this triangle boundary. So let me show you what I mean by that. I'm gonna try to draw some simple sketch here. So let's say you have this triangle as a base, and what I am going to do is to try to pick each edge on each triangle and get the ratio from the first point, the starting point of each edge, and to the end point of each edge. So this, for this edge, this will be the starting point and this will be the end point. Okay. And what I'm gonna do is to use some parameter, which in this case I'm gonna call this t, and t is in between 0 to 1. Okay, which indicates the position on top of this edge. So if it's 0.5, then it's on the middle. If it's 0.25, then it's 25% distance from the starting point to the end point. So somewhere around here. If it's 0.75, it's around here. And what I'm gonna do is to do the same thing. If I choose this one, then do the same thing for all the other edges. So pick the 75% positions, 75 positions for each edge, and then connect these points with a new triangle. And that's pretty much it. Okay. So simple enough. And in order to choose what kind of value that I would like to use for this t, I am going to create some noise related value for each primitive, like maybe this n is equal to 0.3, n is equal to 0.4, n is equal to 0.2 or something like that. And based on those noise value, I'm going to use it for this t value so that you can have kind of a gradational animated pattern by rotating these triangle with each of these. We're using the same rule but different rotational value or ratio value. So the logic is pretty simple. Let's try to do that. Okay, now I am going to, first of all, I'm going to set some groups to this original primitive. Later on, I'm going to use this to differentiate the colors for the background and the foreground. Okay, so I'm going to make this a background group for a primitive. Right. Now, let's use a primitive wrangle. First thing first, let me try to calculate the noise value. Okay, so based on the point position of each primitive, the center point position of each primitive. So, and since I would like to make it periodic so that you can create a loop animation, I am going to first set the end frame. Any frame is fine. Now I'm going to create a time-based value by dividing the current frame by the frame end value. So the value range of this calculation, this equations will be in between 0 to 1 based on this frame position. Okay, if it's at 1, the value will be something close to 0, and if the frame is 100, then this equations will give you 1 as a result. Okay, now I'm going to multiply this by a number of like a periodic iterations, which I'm going to use it for the periodic noise. So let's create some integer parameter. Let's name this period, starting with 1 or 2 or 3, anything. Now, now that I have this time-based value, in this case, I have multiplied 0 to 1 value by 3, then the value will be in between 0 to 3. Now the next thing that I would like to do is to get the noise value based on this frame value and the point position. So the function that I'm going to use is this p noise, which is a periodic noise, which you can create a periodic repeatable loop noise value. Now in order to use this one, you can choose several types of parameters. What I'm going to use today is this one, the last one, using vector 4 and px, py, pz, pt, which is the periodic number for each x, y, z, w coordinate. Okay, so The first three coordinate XYZ is coming from the position, so let's create the position value first. Getting the center point of the primitive and multiply it by some scaling value so that you can control the smoothness of the noise value. Then you already have this fourth value, which is this F value, so keep that as it is. Now I'm going to recreate the position 4 value, which is going to be used as a seed for a periodic noise, which I am going to place position X, position Y, position Z for XYZ, and for the last value I'm going to use F. Okay, now it's time to create a noise value using pnoise. So the first parameter will be position 4, which is the vector 4 value. Now for the other parameters, which is going to be the definition, what's the periodic number for x, y, z, and a w. Now for x, y, z, I don't want to make it periodic, so I'm going to make it -1. For the last one, the periodic number has to be the same as this one right here. So I guess it's a good idea to make it as a variable. I'm gonna make this period, copy this one right here, and for the last parameter here, I'm gonna say period. Okay, forgot to use the semicolon. Okay, let me save this somewhere so that I don't lose the process. Alright. Now let's check this value, how it looks like. I am going to try to apply this into a primitive as an attribute. Let's call this val, and based on this val, I'm going to try to colorize it to see how it looks like. Okay, going to look at the val attribute for a primitive. Now everything seems to have the same value. Now let's see why. I'm going to check the geometry spreadsheet to the primitive, and seems like every value looks the same, so something must be wrong with these setup right here. Okay, one thing I was missing is this scale value. I have just promoted clicking this button. Okay, now raising this value up. Okay, I'll be able to control the smoothness of the noise value, and I'm seeing some kind of pattern starting to happen. Okay, there seems to be a bit of kind of a boundary right here. I can see some boundary right here. Not sure why. Probably because of using this periodic noise, maybe. But what I want to make sure that it is looping. Okay, I think it is. Alright. Now if I try to make this scale, okay, it's not bad at all. Okay, I kind of see some looping pattern right here, based on the position as well. So let's see. Let me check what I need to do for what I am missing with this periodic noise here. So I have this position 4, okay, and I'm using a pnoise. And I want to make sure if using -1 was the right choice. So, use the noise function. Okay. For example, if you are making 2D, If periodic argument is 0, okay, I guess I needed to make this 0 instead of -1. Sorry for that. Oops. Okay, let's check this again. Okay, now it looks more smoother. Okay, looks good. Now let me try to make this. Okay, currently the range of this value is somehow in between 0.2 to 0.7, so let's clamp this so that you'll always get the value in between 0 to 1. Okay, so I am going to do that by using a fit function. And I'm going to make the minimum to be 0.3 and maximum to be 0.7 and remap it in between 0 to 1 like this. Okay, so now I have more contrast on this color. Now maybe using just this noise value might not be that interesting, so I am going to convert this value into an angle-based value and try to use that angle together with some trigonometry function like sine function to make the pattern a bit more interesting. So let's try to do that. So first of all, I'm going to multiply this value by a angle-based value, so pi multiplied by some, I don't know, my wave number. Okay, let's increase this to 5 or something. Now after I have made this as an angle-based value, since the value is currently in between 0 to 1 when it was remapped using a fit function like here, and after that I have multiplied by pi multiplied by some integer value, meaning I have made the range of this value so that this value will be the maximum. Now I can use this with some sine function, and as a result the value you get is in between -1 to 1, which will create some wavy pattern. Now I don't want to have a negative value, so I'm going to use the fit 1 1, which remaps the value in between -1 to 1 to a specific value range. So I'm gonna remap this into 0 to 1 again, and now I'll be able to have a bit more interesting pattern. Now I can control the number of waves, can control the density of the noise, and so on, and the speed of the noise, and so on. Okay, getting interesting. Now I am going to the motivation here, the reason why I have created this value is because I wanted to use this exact value to rotate the triangle on for each of the triangles. Okay, so let's try to do that. I can do it in the same code, but might going to be a bit messy, so I'm going to do that in other primitive wrangle. I don't think the speed doesn't really matter here because it's not a big of a operation here that I'm going to process. So let's try to do this, and in order to process it, it might be a good idea that each of the triangles point are being treated unique, meaning the point doesn't share the same, each triangle doesn't share the same point, but everything is unweld. So to do that, I am going to make all the points unique for each primitive. I'm going to use a facet, then make this unique points. Okay, as a result, every primitive has detached to the neighbors and become independent. The number of primitive doesn't really change, but the number of points have increased almost 3 times or much more. Right. Now let's try to do this. Okay, so what I'm going to do, I would like to check if the value is still visible, available. Okay, still available. Okay, that's good. Now going back here, and as I have shown you in the sketch, what I would like to do is to get 3 points from each triangle, from each primitive. Then I'm going to try to get the position on the edge using a ratio. In this case, I'm going to use the noise-based value. Then pick that point to create a new triangle. Alright, so let's do that. I'm going to just pick all the points from the primitive using prim points. Primnum. Then loop through all the points. So because of this process, the geometry doesn't really have to be triangle, but it could also work with the quad faces, I think, or any number of points for a polygon. I just made a triangle because you can create a clear or clean mesh using a remesh components. But let's say if you could use a quad remesh component, then maybe it might be interesting to deal with the quad faces as well using the same process. Okay, now I am looping through all the points. In order to get the edge information, the starting point and the end point for each triangle's edge, I am going to first get the first point by getting the I index value from the point list. Then for the next point, I could just say I plus I. And in case this goes over the length of PTS, I can calculate the remains with the total number of points, so that it will be reset to 0 when you calculate the remains and when it goes over the length of PTS. Okay, now let's also get the point position for each point number. Position 1 is equal to 0.0 p pt1. Position 2 is equal to 0.0 p pt2. Right. Now, now that I have 2 point positions, let's see how I can use these information to calculate the point on the edge. Now, if I have this position 1, if I have this position 2, and let's say the value is, let's say, around 0.7, and I want to get this point in between position 1 and position 2. Now the position 1 and position 2 is actually the vector coming from 0, 0, 0, which is like an arrow looking like this. Okay. And if you remember how the vector operation works, in order to get this position right here, first of all, you can start by adding this position 1 vector to 0, 0, 0, which will create this vector value. Now from this point, you want to go to this way. To go this way, you can do the subtraction between the position 2 and the position 1. So by doing the subtraction, you first go to the position 2, then position 2 minus position 1 means that you first go to position 2 in a positive direction, then for the negative direction of position 1, which is this way, you go this way. And then you will estimate the final direction from the 0, 0, 0 to the final position, and this is actually the direction you get by subtracting the two vectors. And then you can add this from this point, and if you would like to go like 70%, then you can multiply this length by 70% or 0.7, and there you go, you get the final point position. So this, which means the final equation looks like this: position 1 plus position 2 minus position 1 multiplied by a value. Yeah, that's it. Simple enough. Let's do this. Okay, so the new position vector, new position is position 1 plus position 2 minus position 1 multiplied by a FL. The FL, F at val, the attribute value which comes from the noise value, which is this one right here. Currently it's 0.5, but it's changing based on the time. Alright. Now, now that I have this value, now that I have this new position, I can reposition either 0.1 or 0.2 with this new position. So let's reposition this 0.1 PT1 by updating the point attribute by using set point attrib 0 p pt1 with this new position. Alright, and there you go. And that's pretty much it. If you play it, you can already see these patterns played by changing the triangle face rotating by its own. Looks like it's rotating. Okay, it's too fast. Okay, now let me just rename this. Now that was too easy, I guess. So, how do I say? Triangle rotation or triangle recreation. And then this was a noise value. Okay, and now I can probably set the color based on this value. Let's make the color a bit more interesting. Let's say like two-tone. Yep. Or anything else. Okay. Maybe this is okay. Right. Now, I would like to combine with the background, so let's offset this the whole geometry a little bit to the outside, to the outward. So I'm gonna do that by moving each vertices or points to the normal direction of this primitive. Now currently the primitive doesn't have its normal direction, so let's create that one first. Let's set this to primitive normal. Then going back here, I am going to update this new position by adding a normal direction of the primitive multiplied by some small length. Let's just say offset. Okay, that was too much. Could be a bit smaller. Okay, now I want to try to combine this with a background, which is this one right here. Now, for the new triangles, I would like to make it as something I want to set some different group. Let's say triangle, triangle, and remove the background group. If there is any. Okay. Now let's combine these together. And probably setting the color to this background also might make sense. Oops. So I'm gonna use another color node for the primitive. Any color is fine. Okay, and that's pretty much it. Okay, that was fast, I think. 30 minutes. And I'm just going to create a null node so that I can have all the parameters that you can control with this setup. And if you have, during setting up the parameters, if you have any questions, then let me know. If not, this is pretty much the end of this tutorial for today. It was really quick. And thank you for watching. Okay, so let me uncheck the 4-bit linking. I am going to drag and drop this period, scale, wave num. What else? A triangle recreation offset. And I guess that's pretty much it. Probably I could control these colors as well. And this one as well. Alright. Okay, let's see. So this is the speed of the noise. This is the scale of the noise, the smoothness of the noise value. This is how much wave you want to create. It's pretty interesting. Okay. And offset. This looks like breaking up. Okay. Now these are the colors. Okay, that's much it. Thank you, and alright, so if there's no questions, I would like to end here. I'm going to upload the file to this video description page after this live so that you can download it to check it out. Okay, and yeah, if no questions, let's end the live here. And I would it will be great if you could come back next week at around the same time as well for another type of tutorial. Okay, sometimes it will be really quick like this, sometimes it will be really long, like last time it looks like 3 hours and so on. It really depends on the topic. Okay, thank you very much, and if you would like to support me, there's also a Patreon, so that would also be great. Okay, thank you, and good night, everybody. Thank you for watching.